In this class, I am going to discuss the basement cover relationship, which is important in stratigraphy and also in sedimentology and structural geology. Consider the hard rock, which is called here as the basement. Suppose a depression is produced and there sediments come from outside and that get deposited. This sediment is called cover, as if it is covering the basement material. This cover rock can also be called as a mantle. This is not that crust, mantle and core, that is a different set of terms. Here cover can also be called mantle. In other words, the basement is mantled by the covered material. I referred that the cover material can be sediment, and if it gets compacted it becomes sedimentary rocks, and if it gets metamorphosed it can also become metamorphic rock. Let us see the important information about the basement and the cover. I start with the basement first, and above the basement lies the cover material. So, I have drawn this red line. Here I am going to talk about the basement important statements. Basement at the bottom and cover at the top. So, basement is the lowest or the basal rock unit in a region. This has to be and comes from common sense. It lies beneath an unconformity in regional extent. So, this red line which I have drawn and I am redrawing can be an unconformity, which means that the edge of the basement rock and the edge of the cover rock, there can be a significant difference, millions of years of age gap can be present, and if that is the case, then between basement and cover we in certain cases establish an unconformity. I have already made a lecture on unconformity where the different kinds of unconformity you can look at. I am not discussing here. Next statement, basement is older than the cover. This has to be because it is at the bottom and that is at the top, unless there is an overturn. The age of the basement can vary from 10 million year up to even 2 billion year. These are the general statements we are making from worldwide geoscientists' understanding on the basement and cover relationship. Now, this basement rock is usually igneous or metamorphic rock or hybrid assemblage, and it is usually highly deformed and dominantly crystalline in nature. This basement igneous and metamorphic rock sometimes is called as fundamental gneiss if the basement is gneiss. It is also called as a primitive gneiss. We come across these terms fundamental gneiss when we study the stratigraphy of specific regions, say of India. Now, above the basement lies the cover, and I am going to discuss about the cover. It is also called mantle, as I have referred already in the previous slide. What happens in the cover is the folding followed by faulting is common. However, there are cases where the cover material is less deformed. Now, what the cover material consists of? Sediments or sedimentary rocks, plus minus means with or without interbedded pyroclastics and volcanic flows. These are common. A few interesting statements. Sometimes the word basement is used irrespective of the age connotation. What does this mean? In the previous slide we referred that the age of the basement rock can be very old, 10 million year or 2 billion year, but there are cases where the basement rock, this word basement has been used without any connotation of the age, that very old age, so many million year to so many million year or so many billion year to so much billion year, that connotation is removed. So, in that case what it means? It simply means a rock which is at the bottom and over which sediments have been deposited. This bottom rock is called the basement, whatever be the age. Okay. Why we are interested in basement and cover relationship? Because the basement is important to study exploration of such as hydrocarbon. So, the deep exploration, deep drilling are targeting the basement rocks in many cases. Okay. Now, let us look at the basement cover relationship in this way. Consider that there are Archean rocks as the basement rock and over which the Proterozoic sediments have been deposited. This is a global scenario. In many cases in the places in the world this can be seen, and also this has happened on the Indian territory. These Proterozoic sediments are called the Purana sediments. The rocks can be called as the Purana rocks, and where they are deposited have been called as the Purana basins in India. The Archean Proterozoic timing is around 2500 million year, and the interesting point is that there was a time gap between the Archean rock, very old one, and the Proterozoic sediments which is at the top. Few million years of gaps might be there. So, based on that, this line has been described as the Eparchian unconformity. In Indian stratigraphy, this term Eparchian unconformity comes into picture, and we have in India field evidence of this Eparchian unconformity. So, here in this particular case the Archean rock is the basement and Proterozoic sediment where we are finding the Purana basins can be called as the cover. When someone covers the Indian stratigraphy or any specific terrain oriented stratigraphy, then this knowledge of principle of stratigraphy becomes invaluable. Now, some interesting facts that the basement rock might be faulted or structurally disturbed and remobilized. Faulting, folding, etc. we can say as the structural disturbance, and remobilized means it moves, the material moves due to structural deformation. Loosely speaking, remobilization means movement again, and in this process of structural disturbance sometimes what we say is that the basement gets destroyed. Two manifestations can be found regarding the basement: autochtons when the blocks are stationary, not much movement has happened, and the alloctons when the basement rocks have moved, or the mobile blocks we can say. Now, sometimes the basement rock becomes indistinguishable, that means doing field work you cannot say this is the basement and that is the metamorphosed cover rock. If the basement is igneous or metamorphic rock and the cover rock is simply sedimentary rock, visually it is easy to understand, but if the cover rock gets metamorphosed and the basement is structurally disturbed, then it becomes difficult to recognize in the field. In that case, various geochronologic techniques such as the uranium lead dating, SMND dating and RBSR dating, depending on the suitability, can be performed to distinguish the basement rocks. And in this context, the zircon dating becomes very important. And if by dating we find very old zircon, we understand that there was an old continent present. So, we can say that the evolution of continents can be deciphered if the recycled basement is identified. Now, the basement material and the cover material, sometimes there can be an in between shelly material, we can also call it the basement material. Many places in the world it has been seen that below lies the Precambrian basement rock, over that lies the Cambrian shell and over that some other cover rock. In this case, it is a 3-layer scenario where this shell preferably acts to decouple the cover rock from the Precambrian basement material, uncoupling or decoupling between the basement and the cover material. What does this mean? Is that if we deforming the entire package of Precambrian basement, Cambrian shell and cover rock, the cover rock will behave differently than the Precambrian basement rock. Let me write down what is the meaning of this uncoupling. This means that if the entire package gets deformed, then cover rocks may deform differently from the basement rock, and we have many such examples worldwide. So, the basement cover relationship also talks about a mechanical stratigraphy. Here we can say, or in this diagram, the basement behaves in one way, the cover behaves in another way, because they are different rocks. This is hard igneous or metamorphic rock, whereas this can be sedimentary rock. Now, in terms of the geothermal gradient, the basement and the cover rocks are in different temperature. We know the geothermal gradient normally is, say, 40 degree centigrade per kilometer. As one goes 1 kilometer deep, 40 degree centigrade temperature increases. Naturally, the basement rocks being at the deeper depth is at higher temperature than the cover material. The basement rocks being at greater depth is at higher temperature. Therefore, what happens? The basement rock can behave more plastically or mechanically in a different way than the cover. So, it is a two-layer scenario in this diagram. This is a two-layer scenario. As we have referred here the Cambrian shale, is there any other lithology that can decouple efficiently the basement from the cover material? Suppose there is salt, then this salt will also promote decoupling between what is above it and what is below it. Now, we come to another important point. One of the major problems of the Archean granite greenstone belts is that the nature of basement upon which the greenstone came into existence is difficult to find out. What is the nature of the basement of granite over which the greenstone came into existence? Why it happens? Because the granite or greenstone, because the granite and the greenstone contact might be faulted, or it can be poorly exposed. A severely faulted block becomes difficult to distinguish from the basement rock. Now, let us look at the different kinds of contacts between rocks. This will be important and it will be a very handy classification for us. There can be rock A and B and the contact can be sharp, or there can be a gradational contact between rock A and rock B. Rock A is exposed and then there is a zone where A and B are both found, and then rock B is exposed. We call such contacts as the gradational contact. Unconformity, on which I have delivered an entire lecture, I have not drawn anything here, is another possibility where there are, let us say, one group of rocks and then there is a time gap and then another group of rocks have been deposited. And so, here when we say unconformity, we are bringing a time connotation. That there is a time gap in deposition and that there can be an erosional surface between these two groups of rocks or these two sequence of rocks. Then we can think of conformable contact between rocks. This can be 6th variety. After 4, 5 I can bring 6. Here also a time connotation is there. What is that? From bottom to top, rock A and B are there, and this contact does not indicate a significant time gap, or I can write here no time gap. This will indicate a conformable contact. We can have other kinds of contacts between rocks. Faults can be one example. I have drawn a Listric normal fault here. This is a faulted unit, and here if we look at rock A, adjacent to it rock A will not be found. Let us say rock C is found. So, different rocks may come side by side. There can be another kind of contact which we can call dike. What is that? Say an igneous or a sedimentary unit cut across the country rock, and the rock that cuts is called the dike. There is another spelling available, D-I-K-E, dike. Now, let us see the different types of basement cover relationship. Number 1 is the faulted basement with the basement wedge. Here I have drawn the basement which is faulted, and in my diagram I am showing the reverse fault. We are looking at a vertical cross section. Reverse fault symbols are shown in terms of the half arrows. The basement is faulted and the basement wedges are produced. It is like a wedge geometry has been produced. We can consider this portion as a wedge geometry. So, this is produced under a compressional tectonic regime. If such a compression is applied in both the sides, then this would be produced. There can be a case where the basement got rifted. In that case, we can think of extensional tectonic regime giving Horst and Graben geometry. In that case, we have to put half arrows like this, and here can be sediments being deposited. So, in this case, in this diagram, in this Horst and Graben geometry, this is the basement and here is the cover. In Indian context, the Mesozoic basins in Rajasthan, such as the Jaisalmer basin or the Barmer basin, can be an example where there is basement igneous rocks and over which the Mesozoic sediments were deposited in an extensional tectonic regime in the past. Come to the second possibility, slice of basement rock over the cover rocks forming a basement nappe. In this case, again a compressional tectonic regime is considered where compression in both sides are given, and this basement material got reverse faulted for a very long distance, and this geometry is produced in the vertical cross section. So, what has happened from bottom towards top? Here we have the basement, then the cover, then the basement, then the cover. But this does not mean that this basement is younger than that basement age wise. No, only deformation has brought it at the top. We have used the word nappe here. This is a reverse fault induced many kilometer movement of the basement material has happened, and that is why the word nappe has been used. Let us see the third variety, partially remobilized basement that domed up. Here these red dots indicate the basement which underwent a doming upward, and there is partial remobilization also. What does this mean and how it is reflected in the diagram? I have drawn these curved lines where I have put the same red dots here. So, this is the basement material, whereas inside these curved lines also are the basement material. These two domains are basically indicating remobilized zones of the basement. They got remobilized and they also moved upward. This large scale fold is the doming which has been mentioned over here, and the cover rocks also swelled upward. Now, let us come to the fourth possibility, remobilized core of basement interfolded with cover rock. What does this mean? That the basement rock and the cover rock were interfolded, both got folded, and let us see how it looks. This is the diagram. Here the red dots indicate the basement material. It is strongly folded, and we can also see that the cover material also got folded. They got interfolded in the deformation. What we observe with this diagram and a previous case such as this, here the basement was mainly faulted. Yes, that fault also continues to some extent inside the cover rock, but otherwise the cover rock is not reverse faulted, and here both the basement and the cover rock took part in deformation. The degree of strain will vary because the basement rock and the cover rock are of different composition, therefore their mechanical properties will be different. Now I come to the remobilized basement case. Here the basement cover relationship is a migmatite front and the contact is difficult to recognize. Here is the diagram. The basement rock is intensely folded and the basement cover contact is difficult to recognize. This fold is non-periodic fold, and there can be isolated folds also found within the cross section. So, these are the 5 possible varieties of the basement cover relationship. However, when we do field work, we have to keep our eyes open. Based on what previous authors have seen, these diagrams are the compilation. This does not mean that these are the only possibilities. This is important in all geoscientific studies. We take ideas from the books and research papers. Also, we have to be lenient in the field to expand our findings, but at the same time we cannot be too much lenient in the field that we start accepting everything. So, it is good to do field work with experts for few months and then try to become independent.